My co-founder Eric and I started a company when I was in graduate school at the University of Pennsylvania, studying medical physics to help improve the workflow of medical physicists working in radiation oncology. We ended up selling that company to a medical device company here in Palo Alto called Varian Medical Systems. I worked there as a product manager for a couple of years. While I was there, I learned that, and this was in 2014 or so, learned that hospitals were starting to become concerned that hackers could physically harm patients by using cybersecurity vulnerabilities in the medical devices. And around the same time, there was an episode of a TV show called Homeland in which a terrorist hacks the vice president's pacemaker and kills him. And while I was watching this show with my wife, I said, this is ridiculous. There's no way this could possibly happen. This is impossible. Turns out it's totally possible. In this particular instance, pacemakers communicate with a little iPhone-looking thing called an interrogator over a radio frequency so that the physician can change the settings of the pacemaker. And in 2008, it was found that you needed a username and password to get into this pacemaker setting device. And the username was the name of the manufacturer, and the password was password. So not exactly a super secure way to address these devices. We started looking into this problem. We weren't yet convinced in 2014 that this was a real problem. A couple of years later, a group of cybersecurity researchers found a vulnerability in a St. Jude pacemaker, and rather than reporting it to the FDA or the manufacturer, they partnered with a hedge fund and they shorted the stock of St. Jude. And then the hedge fund guy goes on TV and talks about how terrible this vulnerability is, and the company's gonna go out of business, and raised all of this concern. The short version of the story is St. Jude said these problems don't exist. They were acquired by Abbott. They then said half of the problems do exist, but they're not a big deal. And then they said the other half of the problems do actually exist. And it was the first mandatory recall of an implantable medical device due to a cybersecurity vulnerability. There were 450,000 patients that were told to go into their cardiologist office to get a software update because somebody might be able to hack their pacemaker. So one of the questions that we get regularly is, has anybody ever died from somebody hacking their pacemaker? And while we don't know as an industry if this has ever happened, we do know that St. Jude lost $1 billion of market cap overnight when this vulnerability came out. So companies are losing money due to these vulnerabilities, even if a hacker hasn't actually used this to harm a patient yet. Clicker time. All right, so the FDA in 2016 put regulatory incentives in place to encourage medical device vendors to admit when they are having cybersecurity issues. This is called a vulnerability disclosure. So before the FDA required this, not a lot of them. After the FDA required this, a lot of them. So there's on average about 4.5 vulnerabilities per month that are announced by medical device vendors, many of which result in recalls. So the FDA in 2018 came out with new regulations that say to medical device vendors, if you are submitting a medical device for regulatory clearance, we will not approve it unless it has these cybersecurity features in place. And it just so happens that that list of cybersecurity features is exactly the set of features that Eric and I started building 2 years ago when we started MedCrypt. So if a medical device vendor wants to build cybersecurity features into their devices, it's super easy. You download all these open source libraries and you configure them all and you check them for vulnerabilities. That's a joke, it's not easy. You can just import MedCrypt. So this is a little bit hyperbolic, and Eric, our CTO, hates when I show this slide because this is absolutely an exaggeration. But in about 10 lines of code, a medical device vendor can download our library, get access to really important cryptographic functions that secure the functions of the device, and then monitor those devices when they're out in the field to know if they're under attack. For example, a piece of radiology equipment usually has maybe 2 or 3 user authentication failures per day. We might see a radiology device having 50 user authentication failures in a minute. That would look like somebody programmatically trying to hack a password. This is the sort of thing that we would see in our monitoring. So this is a code sample for the non-engineers in the room. It's really easy to install. There you go. By installing those few lines of code, you're getting the benefit of this very complex security architecture that we have designed to work in everything from a pacemaker all the way up to a CT scanner with just a few lines of code. So progress to date. So we were part of NextCubed in early 2018, I believe late 2017, early 2018. Since then, we've raised a total of $3 million led by ENIAC Ventures. That last fundraising was last May. Our first customer, Reflection Medical, is scheduled to get a 510K clearance of their device in Q2 of this year. Shouldn't say scheduled, they're expecting. We have our first publicly traded customer on board, an X-ray imaging manufacturer whose name I can't tell you yet, and we have pilots going with 5 of the top 30 medical device vendors. So long term, we see an opportunity not just to secure medical devices, but to build an array of cybersecurity products to secure everything in healthcare. Medical devices are just the natural stepping off point to build end-to-end security for essentially every piece of computerized technology in healthcare. We're really building the Symantec of healthcare. Thank you.